All right, class, we're going to take a look at section 14.1, organizing and visualizing data. So first thing that we're going to deal with is a frequency table, and it kind of drives the rest of the ways that we deal with data. So a definition here is we refer to a collection of numerical information as data, or as a distribution. And the set of data listed with their frequencies, in other words, how many of each type of data you have, is called a frequency table distribution. And here we have a problem where we assume that there's 25 viewers that were surveyed to evaluate a preview of an episode of the CBS drama CSI. The possible evaluations were E for excellent, A for above average, V for average, B for below average, and P for poor. And then here are their actual outcomes. This is what a list, just a list of what we've got. So our job is to construct a frequency table with the and figure out what the relative frequency was for each list of evaluations. So we're going to do that over here. So remember, we've got 25 total, so at the end we should be able to add up to 25, hopefully. And so our job is to just count how many E's we have, which here, if we actually counted them up, we'd have 1, 2, 3, 4 E's, okay? And then how many A's we have, and so we're going to have 7 of those, 2, 3, 4, 5, 6, and 7. And notice I'm writing them here. We've got the actual label in this column, and then their frequency, the amount of them that you have over here. And then so we are looking for V. So we have 1, 2, 3, 4, 5, 6, 7, 8 V's, and then you can count again. The B's is 4, and the P's is 2. So you're just counting up, and as I count, I usually mark them off or whatever, underline them to show that I've actually counted. And the total is 25, because if we add this up, there are 25 numbers that we've counted. Okay? So that's a frequency table. Now the relative frequency table is we're going to come over here and actually write that we have the evaluation E. We figure out the relative frequency. So all that means is we actually take 4 and divide it by 25. And it's like getting the probability of, if I randomly pointed my finger at a screen and circled a number, what would it be? No, I circled 3, but if I circled 1, and what would the chance of me be getting actually E if I had closed my eyes to do that? And so here we have, it's 4 divided by 25, which is 0.16. So the relative frequency is 0.16. And here we do it for each one. We take the 7 divided by the 25. We take the 8 divided by 25, and then we do it for the B, which is 4 out of 25, and the P, which is 2 out of 25. So we get all these decimals. Now, if we add this up, there should be a rounding error, but it should add up to 1.0. Often there will be a little rounding error, so you might get like 0.999 or something like that. Really, really close. But in this case, I believe it does actually add up to 1. So this total on the frequency table should add up to how many actual viewers you have, and the relative frequency total should be really, really close to 1, minus some rounding. But if I actually added the fractions up, the fractions would actually end up to be 25 over 25, which is 1. But based on the rounding, it might not. Here we go, moving on. Suppose that we've got 40 school counselors take a test to evaluate their skill at identifying signs of bullying, and they earn the following scores. So percentages, scores, whatever you want out of 100. So what our job is to construct a frequency table and a relative frequency table. So frequency table and relative frequency. So here I've got it all in one chart, and now I'm actually going to show you 2 separate charts for the same information. What I would look at is I see this information starting with the smallest number. I see a 5. I don't see anything smaller than 5, so what I could do is just say it's the range is 50 to 59, and then 60 to 69, and then 70 to 79, and then 80 to 89. Okay, so your range is flexible. Now in the lab, I believe it sets it up for you, but in real life, when you're setting up a frequency table, your frequency is whatever you want it to be for the range of the set. On the last problem, we had set evaluations. Here, I'm just making it up, and you can make it up to be 50 to 55, as you'll see on the next picture that I have for you. But here we go. The way that I set up is 50 to 59, so if I do it this way, I actually need to look through and say, all right, there's 50s. Any more? I go, another one. There's another one. There's another one. There's another one. All right, if I total those up, I got 1, 2, 3, 4, 5 of them. And then now I go my 60s. So here I go 160, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let me know later if I missed one. Sadly, you can't yell at me. Oh, I did. There it is, 11. Sometimes I wish that you could help me out. But here we go. I've got 11 of them. Maybe I still missed one. We'll find out in a little bit. And then 70 to 79. So I got 79 there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 of them. Okay, and then 80 to 89. So I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That looks like we've got all of our numbers now. So if I add this up, hopefully it's up to 40. So yes, we got 5, so that's 0, 1, and that does end up adding, wait, yes, 40. There we go. So 50, but 40, yes. So it does add up to 40, so I'm good. And then your relative frequency would be 5 out of 40, and 11 out of 40, and 13 out of 40. And then 11 out of 40 again. And then you can actually get those decimal approximations, but I'm not going to for this situation. But the bottom line is this should add up to 40 out of 40, which is 1 at the end. So I'm just showing you that I came up with my own range. Now, our textbook example makes smaller ranges. So I like the range that of, of the 50s, the 60s, the 70s, the 80s. And the textbook came up with the 50 to 54, and 55 to 59, 60 to 64, and they broke it down a little smaller. You still end up with 40, but they're just broken up into smaller groupings. Okay, so it's a tighter look at your data. The relative frequency here, you do the same thing, where like this one is there's these 3 out of the 40 that are down here, and that's where you come up with the 0.075. Okay, so it doesn't matter which way you set it up if you're doing it on your own, but I believe the lab is going to do this part for you, and then it's just looking for you to identify numbers that are in those ranges. Okay, so the next step of, once we've figured out a frequency table, the next step is just to come up with a histogram. Okay, a histogram is basically taking a bar graph and making it where they're all touching, the bars are all touching. So it's a little different than what a bar graph actually is, but for this situation, we've got 50 to 54, so I've got 1, 2, 3, 4, 5, 6, 7, 8 different groupings. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8 different groupings. Now the way that this goes, it has to be right next to each other, so I say this is 50 to 54. Well, right after 54 should start 55 to 59. And then right after 59 would be 60 to 64. And right after that would be 65 to 69. And so each one of these are right next to each other. So for example, let's count this up, we got 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so this is 1 through 9. And so our job is to basically make a bar graph where we say our frequency here is 2, but the bars have to touch each other because it's going, our range is from 50 to 54. The next actual number starts right here. So I don't make a space is what I'm trying to get after. So I'll do a different color so we can see the break. But the key here, the weird thing about histograms is there's no space between the bars as far as like bar graph goes. Bar graph usually has spaces between each one. So here we got 60 to 64 is 5 of them. So 1, 2, 3, 4, 5. So there we go here. I should have changed colors, but I'll just won't fill that one in. And then we've got our next one. So we've got 6, and so on. And so then you would just keep going and fill this in, and you would have your whole histogram. Well, I'll finish it. So we've got our next group is 6, We got 65 to 69, and then after that we got 4. So here we've got 4, 1, 2, 3, 4. And then the next one is there's 9 of them. It's our tallest one. Leave that one blank just to keep it separate. 80 to 84, there's 7 of them. So right here is 7. You can see how great of a drawer I am, especially on my screen. And then finally 4 is right here. 1, 2, 3, 4. And there you go. So this is what a histogram looks like. They have to all be touching. And that is the difference between it and a bar graph. Okay. Now here we go. Stem and leaf plot of data. So same data. The frequency table here is not necessary, but it might be helpful. At least you'll know how many numbers you've got in the actual frequency or the actual stem and leaf plot. But here's how this goes. What I like to do again is go by tens, which you kind of have to here. But what you do is kind of like counting like a kindergartner does, where you say, I've got my tens column, and then I've got my ones. Okay, so in other words, I'm saying, here's my 5 for 50s, my 60s, my 70s, my 80s. Okay, and then we have to go through and say, all right, well, here's 79. So I go 7, and then I put a 9 right there. And then 60, then I put a 62 right here. So in other words, this is breaking it up. And usually you don't put these separating lines. Sorry, talk. 87, but 87. And then here's where it gets more unique, is 84. What you do is you just put a comma and put a 4. In other words, when you're looking at it, it reads, I had an 87 and I had an 84. Okay, and then you keep going. 53, 76. So I put a 6 here. And then 67. So 6 and put a 7. And then 73. And then 82. And then 68. And then 82. And now notice, even though I had a 2, I put another one because it shows that I have 2 82s. 79, 61, 51, 66. I'm going to end after this row because I think this is a lot for me to just do in the video. 77, 78, 66, and 86, and 17. Okay, now the interesting thing to end with is you actually put a 0 there for 7D. Okay, and of course I'm not done with the data, but you would keep going, but I think you've got the point from the video at least as to how a stem and leaf plot goes. So here, single stem with a 2 data set comparison. So here what you're going to do is break it down the same way. So you have a problem like this where you got set A and set B. So you still look at what data you have as far as what your tens category has to be. And then over here you've got ones, and we're going to say that this is the ones for set A. And you don't actually have to label it like that, but there it is, ones for set A. And then over here we're going to put ones for set B. So check this out. I do the top the same way I was doing the last problem, where it's 29, 32, 34, 43. So I got that top row done. And then 37, 33, 42, and then 18. Okay? Got all those. So this is all set A done. And now I just do set B on the left. So I got 32, 38, 22, 39, 21, 29, 22, and finally 25. Oops, it's supposed to be 5. Okay, so it's just doing one set on the left and one set on the right. Okay, and that's the difference for this particular problem, where it says to do the 2 data sets for comparison. Okay, and that's it for this section. So if you have any specific questions, use the Ask My Instructor feature of the lab.